Hello dear learners, today I welcome you for lesson 3 of chapter 3, that is forces. Here is the contact information. If you face any difficulty regarding lesson, you can contact. The learning outcomes of today's lesson are that you should be able to state what is meant by Newton's third law of motion. You should be able to identify action-reaction forces acting on two interacting bodies. You should be able to state what is meant by friction. The content which we are going to cover in today's lesson is that Newton's third law of motion, examples of action-reaction pairs, friction, and there will be practice questions as well. Newton's third law of motion. If you think about this thing, that when you do swimming in a pool, when you do swimming in a pool, do you push your feet against the wall, or what you do, you push the water with your hands and feet to drive yourself forward? When you do this, you are actually applying the Newton's third law of motion. So from here we can state that if a body A exerts a force on body B, means if one body is exerting some force on another body, then the body B will also exert an equal and opposite force on body A. If one body is applying some force in one direction to a body, to another body, then that body will also apply same amount of force to that body but in the opposite direction. So if you see here the example that this boy is going to start swimming. So if you see, the boy is going to push this wall. So there will be a force that will be known as action force, and corresponding to this action some reaction will take place, and that reaction force of wall propels, moves this swimmer, this boy, forwards. What happens? That boy apply force on this wall, and wall will also apply some reaction force, some opposite force, so that the swimmer or the boy can move forward. When the boy will move forward, then with the help of hands and legs, the boy will apply force to water. That will be action force, and in correspondence to that action force, water will also apply some force and the swimmer will move forward. So here you can see that action force, that is F, and reaction force, that is represented by R, occur as a pair. They are not occurring single, the force is occurring here, they are occurring together. So we say that it is in a pair. They are equal in magnitude. If force F is having some amount, same amount this reaction force R is also having, but they are acting in opposite direction. So this is your Newton's third law of motion. So if there is action, then reaction will also occur. So that is your Newton's third law of motion. Here are some examples which are related to Newton's third law of motion, that is going to show you action-reaction pair, or you can say that two forces acting as a pair. In previous slide we have seen in example that for every action there is an equal and opposite reaction. In previous example, the boy was applying some force to the wall, that was action, and there is an equal same amount of force which is exerted by the wall to the boy, but it was in the opposite direction, so there was a reaction. So same is going to be applied here in the few examples. If you see here, we have a ball. When we throw a ball from certain height, what will happen? It will come down, and when it hits the surface, then there is some force which is going to act on this ball, and ball will move upwards. So here is again acting two pairs. One is action, another one is reaction. When we throw a ball, ball is coming downwards, and it is your action when this ball is going to hit this surface. In correspondence to that, when the surface is going to apply some force, that will be a reaction force, and the ball will move up. And in this way, a ball bounces up and down because action and reaction are occurring in a pair. Same is the case here. What happens when the action in this is that when you open this mouth of the balloon, air rushes out or down. In correspondence to this, reaction is that balloon goes up. So air rushes out and balloon goes up because the gas or these molecules are coming outside. And in correspondence to that, the balloon is facing some reaction and balloon moves upward. And one more example is, for example, a ball is coming towards this bat. What happens? As the ball will hit this bat, then you will apply some force to move this ball to a particular direction or to some direction. What will happen? As the ball is going to hit this, in this will be your action, and in reaction the object 2, that is bat, it will hit the ball or apply some force, that will be your reaction force. So both the forces will have same magnitude, but they will be in opposite direction. Now we are going to discuss about friction. Friction is known as contact force. Friction is known as contact force because it will always occur when two objects or two surfaces are in contact with each other. So friction opposes or tend to oppose or tend to resist the motion between surfaces in contact. If one object is in contact with the other surface or other object, what will happen if we move one surface or one object, then there will be some resistance in the motion of that object. Why? Because of friction. Or you can say the force that opposes the motion of moving object is called friction. As I have said in the example, that if you have two objects in contact with each other, if you slide or move one object, you will face that there is some resistance. There is a force that resists the motion of moving objects. So that is known as friction force. So here is a question: why this force opposes motion? Because no surface is perfectly smooth. No surface is perfectly smooth. So a surface that appears to be smooth also has pits and bumps. Means to say that if we see a smooth surface which appears that it is smooth, it also has some gaps. And we say that there are some pits and bumps. And that can only be seen under a microscope. If you see your finger, there are a huge pits and bumps when you see it under a microscope. Here is one example. Two wooden blocks with their polished surfaces are in contact. When we polish any surface, we say that there is some smoothness. But if we take two wooden blocks with their polished surfaces and they are in contact with each other, a magnified view of two smooth surfaces in contact shows the gaps, that is pits and bumps. If you see here, this is the magnified view that is between these two objects, and this is between these two objects. So there is a gap and contact between them. The contact points, these contact points between the two surfaces form a sort of cold welds. So what happens? This interlocking of these gaps is basically creating a friction. These cold welds resist the surfaces from sliding over each other. Cold welds are these bits and bumps, or you can say the where two surfaces are getting interlocked. That is your cold welds, and cold welds resist the surfaces from sliding over each other. Even if you take one example, if you are sitting and listening this lesson, if you take your finger and rub it on your any surface, if you it is a table in front of you or a book in front of you, rub your fingers slightly on that surface. You will face that the surface is resisting the finger to move on that smooth surface. Why it is happening? Because if you see your finger under the microscope, you will see huge gaps, big gaps. You will see pits and bumps, because our finger, or the skin of our finger, is also not perfectly smooth. It just appears that it is smooth. Friction. Remember, if a force is applied to move an object towards right, friction will act towards the left. Remember this thing. Friction is always acting in the opposite direction. For example, if any object is falling from certain height, that object will face some air resistance. And air resistance is occurring in the opposite direction, and same is the friction. If the applied force is removed, for example, if you are applying the force on an object to move it towards some direction, and if that applied force is removed, friction will cause the object to slow down, because then only the force which will be present there, that will be friction, and that will cause the object to slow down, and that object will come to a stop position eventually. Why friction is required? Friction is needed to walk on the ground. If there will be no friction, then we will be unable to walk on the ground, because then the surface will become so slippery that we will be not able to walk on the ground. We will fall down. So it is required. It is risky to run on wet floor with shoes that have smooth soles. If you see your soles of the shoes, you have some grooves. If grooves are more, then what happens? The grip of the shoe with the ground will be more strong, because friction is more. Then if that sole is just smooth, no grooves are there, then it will be slippery. You will be unable to walk even on the dry floor. So it is required that friction must be there. Athletes use special shoes that have extraordinary ground grip. Such shoes prevent them from slipping while running fast. To stop the bicycle, we need friction. So, negative and positive effects of friction will be covered in the next lesson. So, I hope so you are clear about this friction topic, that what is friction. Here are practice questions. Question 1 is, can you lean against a wall without slipping if friction is absent? If no friction is present, can you lean against a wall? So explain your answer. And we have seen that why friction is required in previous slide. We need friction to have a good grip. So you have to think that in the example which we have discussed, that for walking on the surface we need friction. So what if friction is absent? Can we lean against a wall? And there we discussed, I said that if friction is absent, then you will be not able to walk. You will fall down. So can you lean against a wall without slipping if friction is absent? Question 2. How friction is important in our daily activities? So you have to mention the answer for this. It will be good if you write your answers in the comment section. That's all from my side. Thank you so much. God bless you.